Hello everyone. Today, me, Bhavya Sura, and my partner Manav Rupani are going to present the vulnerabilities that we found in PHP programming language. This is a part of internal assessment to secure coding. For finding the vulnerabilities in PHP, we use the damn vulnerable web app instead of writing our own code and testing it out. So let's get to the vulnerabilities. First, we identified the path traversal vulnerability. Looking through the code of damn vulnerable web app, we identified some parts that do not check the URL, that do not validate the URL or check that if the URL has been manipulated. So we decided to exploit the path traversal vulnerability. We did so by uh, like we did so by displaying the password file of our Linux machine, and it worked very well. Uh, this the step is only simple that we manipulated the URL to go to that directory where the password file resides. The mitigation of path traversal vulnerability is pretty simple. We have to just validate the URL and avoid the user to manipulate the URL. Only the two basic functions that PHP provides can be used: the base name function and real path function. The base name function returns only the uh, file name or the path of the file name, whereas the real path function returns the file that if it exists and has executable permission in the hierarchy. Next, as we were observing the source code, we also came across a piece of code that had the remote file inclusion vulnerability. Remote file inclusion vulnerability involves the attack involves including any arbitrary file from remote location and executing the arbitrary code on the application or the server. So the diagram is self-explanatory over here. Uh, the steps we followed, we have mentioned the steps. We first created a bash file that consisted of reverse shell script, and we also used the netcat command to open up server on our own side. Then we modified the URL to the IP address and the name of the file that we had created. Uh, then we get a reverse shell of the entire application, as we can see in the screenshot. Then after getting the reverse shell, we have access to all the files that are stored in the location where the application was stored, and we can include a file, a malicious script, or anything just like we did over here as an example. So this is pretty much vast top 10 vulnerabilities, and the mitigation is also serious. The mitigation here says that we recommended that using a whitelist is for for safe files, because which also avoids manual which also avoids user manipulation of the URL. We can also allow that the user input. We can also avoid user input by allowing certain expressions for the same. Another way is by using a array to map the page parameter from the link to actual file names. Means that only which file name are present in our directory, only that are permitted. Any other name of the URL is not permitted. A snippet of the code we have also given for further a better understanding of that concept, which is this. The third vulnerability we explored is a command injection vulnerability, which was provided by DBWA itself. Command injection is basically execution of arbitrary code on the target system. Uh, so let us see the steps that how we exploited this command injection vulnerability. We first check out the code of the form that has been provided, and we see that the input is not like they are not validating the input or checking for any like commands or characters or special characters. So we can easily execute the command over here, like this one, and we can get the path of what is the current path that the application is residing in. Then in another level of security, we see that they have certain whitelisted characters, but not all. So we see that we can again exploit it by playing around that stuff. We can execute commands by using the pipe operator over here and getting the output on the same page itself. So we did this a lot of times and we find out the mitigation as well. Mitigation would be they have used the shell execute command of PHP, but they have not used the escape shell argument command, which says that every meta character in the string will be escaped in the string and will be added as a code. So it will only print the command and not execute the command every time a command is entered in an input, which is a kind of input validation. We have also provided a code snippet for the same, saying that how the escape shell arg is executed or how it is used in PHP. Next thing is we validate the user input. Validating user input in PHP differs from the level of security that has been provided. So we also have a basic snapshot of how the validated user input looks like for the given field here, which is we have included certain whitelisted characters and blocked special characters as well as some commands or codes. The next vulnerabilities will be explained by Manav.
So, the next vulnerability I'll be discussing is CSRF, or cross-site request forgery. So it is usually used to compromise the target's web sessions and logins, and where we try to get his session or hijack his session. Now, we perform this activity on DVW itself. The diagram shows how the CSRF attack works. So as you can see in the screenshot, this is a change password page of the DVW, and this changes the password. But as you can see, the URL, if we use the URL, if we can modify the URL and make the user run this URL on his end, trick him into clicking a button, then it would change the password, and we could supply what password would be set again or on changed one. So as you can see in the next part, I have provided this URL where it says password new is equals to 1234 and conf is equals to 1234. Basically, we are resetting the password, and we are tricking the user to clicking into a button that loads this URL, and it will change the password automatically. So as you can see in the exploited code, there is no such defense against this, like no CSRF tokens, etc. So it was easier to exploit. So when talking about mitigation, the first thing that comes around is CSRF tokens. Whenever a person or a user logs into a website, he is provided a CSRF token which has a limited time validity, so that any user who has the CSRF token can only access or modify the web contents. So if an attacker tries it, he won't be able to successfully attack because he won't be possessing the CSRF tokens. Along with that, there are multiple other steps that could be followed, like same side attribute for cookies, referrer header checks, etc. that can be done for CSRF attacks. So next would be XSS or cross-site scripting. Now this is a stored XSS. So stored XSS is where the malicious JavaScript code is stored on the target's machine and is loaded every time the user boots in again. This is your majorly browser hijacking, the part of browser hijacking. So if you see the diagram, this is how it works. And this is the XSS page of DVW. So on a lower level security, you could see that in the message I'm directly importing a JavaScript message, a JavaScript snippet where I'm trying to print the document cookie of the user, and as you can see the result, the cookie information is provided with the session ID, etc. But going forward, on the second level, the defenses have been up. In this is the low level security where there's no such defense. But on the next page, you could see that there is a strip tag. Sorry, not strip. There is a script remover tag under name. It says string.replace for script. So we basically cannot use a script tag. But as you can see in the exploited code further, I have developed a new attack payload. Under this, I have used a script in small and caps in different combinations, where I was able to exploit since the code only had script in smaller text, and we were able to again hijack and penetrate through the defenses, and again we get the security cookie and IDs. And the last highest level of security, where they had trimmed every part of the script using regex. So here what we did is, instead of using the script tag, we used the image tag, relying on its error attribute. So if you see in the exploited part, Here, if I zoom in the message, there is differences implied. So we didn't do it in the message part, but now we did it in the name part. First, we had to increase the size of the name input feed so that our code snippet could go in. So I increased the max length to 60, and then if you could see, there's an image source, which is for sure a wrong link, and we want on the on error part to be executed, and in that we have provided the document cookie to be printed upon. And as you can see, we get the cookie as well. So these are three levels of XSS that were exploited. Basically, this is a part of input validation. So if it is done well, where any type of characters, any type of tags that could potentially execute JavaScript codes shall be refrained upon. That shall be defended well. And also, apart from directly JavaScript, as you saw, we used image tag and its on error attributes. We have to make sure we have a blacklist of all such tags that can potentially cause JS code to run on the website. So that is for JavaScript mitigations. And lastly, we have SQL injection. So SQL injection again is a part of input validation again. It basically throttles input validation. So this is a low-level SQL injection security provided by DBWA. So as you can see, we have a user ID field where we are supposed to input the user ID. Here we are basically using a union select query. And we were able to get the user and password from users, but we got the password in encrypted format. Now, since this was DBWA, the passwords are stored in MD5 format, which is breakable nowadays. So we took the MD5 hash and we went to a website that is dedicated to cracking these hashes, and we got the password in a clear text. So this is how it works. Now, for medium level security, we used Burp Suite to intercept the requests. Here they had changed the input field to drop down, where basically they used select tags for providing the options. Now, using Burp Suite, we modified the select tags. Actually, the source code didn't have any mechanisms against modifications of select tags and attributes. So what we did is we exploited that using Burp Suite, and we imported malicious code. We used our SQL injection. As you can see here, ID is equals to 1 plus or plus 1 is equals to 1. That is our malicious SQL injection. And we get all the IDs in the result. If you could see user ID 1, we get all the user IDs in one fetch. So if in the case that some entries would have been protected, or if they were not provided in the options but would have been existed in the table, we would have got them. And lastly, for high level security, again we had to use Burp Suite. We modified the source code. So here you can see now, again the same thing has been run, but on the session ID. The input was for session ID. We again put our 1 is equal to 1. This is a very trivial SQL injection. And again, we were able to fetch all the username entries that are present in the database. If you could see the result. So this is the exact SQL injection, 1 or 1, and then we comment any defense or arbitrary code that follows it. So for mitigation, again we have to check for any input validations. We need to clear off any commands, any SQL keywords, etc. that can be potentially there in the input. Second could be, since we are talking about PHP, PHP offers SQL prepare function that actually prepares SQL queries before it executes directly. So this provides a protection. It doesn't accept such injection SQL codes. And secondly, we could use parameterized queries along with prepared statements. And lastly, we could ensure that database account permissions are set accordingly so that given user does not able to modify the database in any condition. So yeah, that was all. We discussed 6 vulnerabilities. These are the references for all the documentations, articles, and videos we referred. Concluding this video and our presentation would be that these vulnerabilities are very trivial nowadays. Some of these are already present in the OWASP top 10. So SQL injection, XSS, as well as command injection, etc. are all there in the OWASP top 10, and we shall be aware of how these vulnerabilities are exploited and how we should defend against them. So that was our thank you.